Good morning, all. Here we're at work on a Saturday again. Here I have a Lafert Servo motor, and it is type B38D 8I 3M5 BE90000. The feedback of this Lafert Servo motor is Hall effect and encoder. A bar, B bar, and Z bar. That's the encoder feedback. Has 3 Hall effect output. I'm going to use this Lafert servo motor to test the Allen Bradley servo drive, and its model number is 2098-DSD-150. It requires that Hall effect and encoder feedback. But this is the only motor in the shop. I don't have a standard Allen Bradley motor, but I do have this Lafert servo motor. This is the only motor in the shop that I have that has that feedback. Now, this is a non-standard motor. Otherwise, we could just plug and play and select the proper servo motor in the UltraWare software, upload that to the drive, and we'd be good to go. But we have to set that drive up to run this non-Allen Bradley motor. So what I want to do, to get into the ballpark, I want to find out the winding inductance and the winding resistance, and we're going to use that as 2 parameters in the setup program, the motor configuration program. I'll show you that. We'll get close to that laptop and I'll show you all that, and then we'll hook the drive up and run it. I had to make an adapter cable. I'll show you that too. I'll give you the drawings on that. I had to make an adapter cable to go from the Lafert servo motor to the CN2 DB15 high density connector on the drive. And this thing turned into a lot of work. So here, let's turn on our Sencor model LC103. We're going to do lead 0, open test first. That passed. Now we'll short the clip and we'll do lead 0 short test. That passed. Okay. I've got the U, V, and W here. I'm going to click the Sencor onto it. There's U and V. Select coils on the Sencor and go to inductor value. We have 87.8 millihenries. Let me write that down. U to V is 87.8 millihenries. Now we'll go U to W, and the Sencor says 90.1 millihenries. Let's write that down. And now we'll go V to W. We have 87.3 millihenries. Now these aren't the inductance values of a motor that's running. This is with the motor stopped. With the motor running, the inductance values would be different, but this is just to give us a starting point for the motor configuration. There's our inductance. Let's turn that off. Let's go get our ohm meter. All right. Let's set our meter in resistance mode. Looks like I got to get a new battery. Got the battery low symbol on. Here's resistance from U to V, 28.6 ohms. Wrote that down. Here's U to W, 28.7 ohms. Here is V to W, 28.7 ohms. So now we have our inductance of the windings and the resistance of the windings. Let's go hook this motor up to the drive. We'll power it up. I've got two motors here to bookend the Lafert servo motors, so if things run wildly away, it won't be bouncing all over the desktop and dropping onto the floor. That'd be horrible. There we go. Now this Lafert servo motor has a DC brake. I'll have to hook that up. There's the feedback cable. You lay that across there. We're going to hook up U, V, and W of the Lafert servo motor to the drive. There's U. Get untangled here. V, one more. There's W. We hook up the brake. It's a 24-volt DC mechanical brake. Goes to the yellow wire. 24-volt DC ground goes to the green wire. Don't short those wires together, Peepaw. You'll have sparks. Okay. Let's see if the brake releases. Good. You don't want to run this with that brake turned on. If that brake is engaged, you try to run this motor, you're going to overcurrent your drive. Up here is my drive enable. That'll run the motor. That connects to these two pins right here. And I'll show you these hookups. And then over here, I have a speed pot connected to this power supply. And that goes to these two pins right here. I didn't have that connector. That's a 44-pin DB connector. I didn't have that. It's got 3 rows. I didn't have that connector, but I had some small pins, and I snuck the small pins into the connector holes. So I had to separate these two pins here with a piece of cardboard. They were so close together. Let's hook up our feedback. Here's my homemade cable. This connects to the Lafert cable, feedback cable, and this right here connects to the drive CM2 connector. There is all the connections for our motor to drive. This connector right here is the communications cable that goes to the laptop. Okay, we just released the brake. We have 12 volts for our drive enable, our run signal going into the CM1 connector. We have our power supply for the speed pot. We're going to apply 220 volts 3-phase AC to L1, L2, and L3. Let's get plugged into the wall. All right, here we go. I heard the pre-charge contactor energize inside the drive. The cooling fans come up, and the 7-segment display is running around in a circle with a decimal point. All right, now let's get close to the laptop and we'll configure that Lafert Servo motor to run with that Allen Bradley servo drive. Okay, so we need to configure the drive to run with that Lafert servo motor. So we click on motor configuration, go over here, click motors.mdb, motor database, and we're going to click new rotary motor. Click on that, and here, let me move the screen a little bit closer so you can see the words a little bit better. Now here's the configuration program to set up a non-standard motor to run with that Allen Bradley servo drive. The program automatically assigns a model number, and ours is set to 411. Here's your torque constant and inertia. I'm going to leave those alone. Poles per revolution, right now set to 8. I'm going to leave that there. Now we found our resistance to be 28 ohms and our inductance to be about 88 millihenries. We found that on the Sencor. Now the running resistance and inductance, of course, will be different, but this will get us into the ballpark. The data plate for the motor says 157 volts, so we're going to add that in there. The data plate also says 3,000 revolutions per minute. I'm going to back the intermittent current off a little bit. We'll go to 10. I'm going to leave the continuous current at 5. We can change those later if we need to. Up here is the feedback type. Encoder type is incremental. Commutation type, there's 3 choices here, but sinusoidal is the one. The other is brush, and the second one is trapezoid, but we're going to leave it sinusoidal. The startup type, Hall effect inputs. We're going to leave the Hall input offset to 0 degrees. Lines per revolution, we'll leave that at 2,000. Now down here's the thermal. We have integral thermostat. That's the thermostatic switch inside the motor. We'll leave that checked. We'll turn the software protection off. That's calculated thermal based on the voltage and the current of the motor. We have no gearbox, so we'll leave that unchecked. Now we can close this. Okay, we're done here. We can close that. And the next thing we're going to do is we're going to communicate to the drive with the UltraWare software. So now we have the motor configured. We have 3 options here. Open last file, original parameters received. Open an existing file, or create a new file. We're going to open the last file, original parameters received. Click on OK. It says drive has been added to the workspace. Double click on the drive icon to begin basic setup. Okay, it's found the drive. Again, it says drive has been added to the workspace. Double click on the drive icon to begin basic setup. Okay, here is the online drive. This is the drive we're going to talk to. This one right here. Down here is the offline original parameters received with the drive. We don't need to worry about these. When I first powered up the drive and started communicating to it, I saved the parameters and named them original parameters received with the drive. We're only worried about the actual drive here on the bench. That's these menu items right here. Now, one thing, when you first try to communicate to this drive and it cannot find the drive, go over here to Tools, Serial Port, and check your COM parameters. You might be connected to COM 2, but the software is connected to COM 1, so you'll have to drop this down and select the correct COM port. But more than likely, your baud rate will not be correct. This drive came into the shop set to a baud rate of 19.2K. And the software, the UltraWare software, cannot find the drive. So I had to select different COM parameters until it started talking. And this drive was set to 38.4K baud. The format is always 8 data bits, no parity for this Allen Bradley drive, so you don't need to change that, but these first two items you might have to. Let's go to motor, collect on the motor menu item. We're going to type in 411. That was our motor. I'm going to refresh that window by clicking on this button over here. Let's see. Rated voltage 157, resistance 28 ohms, inductance 88 millihenries. Down here, max speed 3000 RPM, intermittent current 10 amps, continuous current 5 amps. That's good. And if you scroll down, there's a few more items that we selected also, having to do with feedback and the thermal protection. Well, there we go. It's been entered into the drive. Let's back up and see how that motor runs. Here's my enable switch. There we go. We're running. We're running that Lafert Servo motor on an Allen Bradley servo drive. Speed it up. I got a speed pot right here. Oh, she's a sweetheart. She runs good. Let's slow her down. That is nice. There you go, folks. That's how you run a non-Allen Bradley servo motor on an Allen Bradley servo drive. Now you can find that software on the internet. Just search Allen Bradley UltraWare. It'll be out there. Let's get closer to that motor. You can see it rotating. That yellow cap on the shaft of the motor holds the keyway from getting lost. When it's attached to the machine, that yellow cap won't be there. Alright folks, at the end of the video I'll put my drawings up. Especially that homemade feedback cable I had to make to adapt that Lafert servo motor to the Allen Bradley drive's feedback connector. That way, y'all can run your non-standard motor on an Allen Bradley servo drive. Alright all. Thank you much for stopping by. I always enjoy it when you come over to see what we're working on next. Gets pretty interesting around here, doesn't it? Okay. Have a good day, folks. Enjoy the day with your family. We'll see you next time. Evening all. Now here is my homemade cable to connect that Lafert servo motor to the Allen Bradley servo drive. Now look here. I've had this meter for a long time, and this meter helps me out around the house. And my fluke meter gave up the ghost a day or two ago, and now this meter is going to step into the breach. She'll do alright. She'll do alright. She'll be a good meter for me. Now here is the DB15 female connector that connects to the Lafert servo motor. Here is the DB15 high density male connector that connects to the drive. Now, let me get my glasses on so I can see what I'm doing. Here is Hall Effect W, Hall Effect V, and Hall Effect U. 11 on the motor side connects to pin 8 S3 on the drive side. Pin 10 Hall Effect V connects to pin 13 S2 on the drive side. Hall Effect U pin 12 connects to pin 12 S1 on the drive side. That's nice how that worked out, 12 to 12. It don't happen very often. Now for positioning, we have B plus, B minus, Z plus, Z minus, A plus, A minus. That's B, B bar, Z, Z bar, A bar. B, pin 1, on the motor side, connects to BM plus, pin 3 on the drive side. B bar, pin 2, on the motor side, connects to pin 4, BM minus, on the drive side. Here we have Z plus, Z on 3 connects to 5. I plus, that's index. Here we call this Z on the Lafert motor, on the Lafert servo motor, but the drive wants to be called index. Here's Z bar, pin 4, to index minus, pin 10. A on pin 5 to pin 1, AM plus. A bar, pin 6 on the motor side to pin 2, AM minus on the drive side. Now we've got to power up that electronics in the servo motor feedback unit. And so on pin 7, that's plus 5 volts to power up the encoder and Hall effects. Pin 14 of the drive provides that 5 volts out to the encoder. Now here is 9. Pin 9 is ground of that 5 volts from the drive. Pin 6 on the drive side. Now, to disable any kind of thermal alarm, we ground TS pin 11 back to pin 6 common on the drive side. If we left that open, we'd have a thermal alarm. Nice. Nice. Alright. Y'all don't be too hard on my new meter. This is the one. But she's gonna do all right. She's got some big shoes to fill. She'll do all right. Let's go to work, girl. All right, folks. I gotta go into the backyard and make sure the birds are being fed and the basil and chives are being watered so they don't shrivel up in the sunshine. Have a good day, folks. Have a good day. We're doing all right around here, and I hope y'all are too.